Hello students, this is our first introduction to MeTTa programming language. So most of you might be wondering what this kind of language is and what we will be using it for. So I'll try to give you a brief overview of what this language looks like, and as well as the features it has, how it's working, why is it developed, and what's its main primary use cases. So try to follow up and make sure to ask us any questions in case you have some. So let's start with the definition. So what does actually MeTTa mean? So MeTTa is actually stands for an abbreviation. It stands for Meta Type Talk programming language. So that's the abbreviation that we'll be using for it. Nothing fancy, you don't need to worry about it too much. You can just call it MeTTa for now. But this is a programming language developed by SingularityNet for their new AI AGI infrastructure, which is called Hyperon. So I'll try to go over some brief definitions of keywords and as well as some of the terminologies you might encounter when you are learning this new programming language. So that's more or less what's going to be covered in this session. So the first thing is, what kind of paradigm is this programming language following? So there are a lot of different paradigms, but this programming language follows two of them. So this is what makes it a bit unique, because it's a combination of two different programming paradigms. The first one is functional programming paradigm. The second one is going to be logical programming paradigm. So to give you a small introduction of what functional is and what logical is, so that you can get the sense of the type of language we're dealing with, let me just go over what functional means, and I'll go over a little bit over what logical means. So for functional programming language, we meant by that some few characteristic features. The first characteristic features is like it's dealing mostly by defining functions and utilizing those functions instead of some keywords like in other programming languages. So what I mean by that is, if you take a look at Python, for example, in Python you have different keywords. For example, you have if, for loops, you have different conditional definitions like switch statements, but those are not actually considered as a function. Those are just built-in keywords for that programming language. But when you come to MeTTa, every single keyword you encounter is going to be treated as a function. What that means is that in this functional paradigm, you don't really have anything outside of a function, and you try to define every operation of the programming language using functions. So that means an if statement is a function. If you are trying to define or declare a variable, the way you do that is through a function. If you're trying to do some even side effects like print to the terminal, you're also going to be doing that using a function, which is kind of obvious because in Python you also do the same thing using functions, but that's basically the idea. You always deal with functions. And the other characteristics of this functional programming paradigm is that you don't really have a side effect. So what I mean by side effect is, if, for example, it's better to explain it in an example. So if, for example, you have a Python code, if you can define a global variable somewhere and then use that global variable in your for loop, in your function, which can be accessed and modified. So that's kind of like what a side effect means. If you have a declared variable and if another function tries to modify that variable or tries to change the value of that variable, that's considered as a side effect. So this is like a crude analogy, not the right terminology for now, because I'm just trying to get you guys started into this programming paradigm, but later on down the road we'll explain what exactly this means in a different programming language. But for now, it's better just if you guys understand that if a function takes a variable, a global variable, and tries to modify that variable and change the global variable from within the function, that function is considered to be doing a side effect. So based on the terminology, you can even think of it like this function is not doing everything inside it. It's also doing something outside of the function, which is referred to it by the variable. So if I have a variable declared A outside of the function, I pass that variable A to the function tries to do some computation and change that variable A, then all of a sudden the variable value is also changed globally for everything in the code. So that's what we mean by side effect. So in order to avoid that, MeTTa and other functional programming paradigms have this way of doing things, which is defining pure functions. So what we mean by pure functions is functions that just don't do any side effects. Or another way of defining it would be like a function that is only constrained to the number of parameters, to the value of the parameters you give it, and also to the logic it's doing within the code block of that function definition. So if you give this function the same variable inputs, it will always output the same variables, the same result, not the same variable, it will always output the same result, and it will not change anything else. Everything that's changed will be limited to the scope of that function. So these kind of functions are called pure functions. So in MeTTa, what this means is that, first of all, you cannot modify a variable. So a variable, once declared, that's going to be fixed. We will see an example later on. The second thing is functions can't intuitively modify something outside of their scope. So we have a workaround for that, but ideally you want the function to be pure so that it will not modify anything outside of the scope of the language. So this is just to give you what this functional paradigms will look like. And another thing you may come across is that these other programming paradigms, like imperative paradigms or like Python, as for example, you have these for loops, you have these different keywords that lets you do iterations. But those iterations highly rely upon some kind of side effect to, for example, a counter variable. But now in MeTTa, we don't really have those kind of keywords. What we have is just functions. So one may ask, like, how do we do an iteration using a function then? Which is where recursion comes in. So in functional programming paradigm, you always use a recursion as a way of iterating over some kind of data structure or some kind of doing a logic again and again for X amount of time. So you do that using only recursion. You can theoretically build up, even practically build up over this recursion logic so that you can get some higher order functions that will enable you to have an abstracted way of like doing this iteration. We'll come across these functions later on down the road, but these kind of functions always under the hood work using recursion. So you can iterate or you can do some logic repeatedly using a recursion. So we will also cover that somewhere down the road. So we don't have for loops, we don't have iteration, we don't have a variable update. We don't have a lot of things in MeTTa, all because MeTTa tries to follow a functional paradigm. So that's one of the paradigms. The second paradigm would be a logical programming paradigm. In logical programming paradigm, you have different way of doing things. So, for example, a very good example might be Prolog as an example of logical paradigm, but I'll try to give you kind of an approximation to Prolog, which is going to be an SQL. So in logical programming paradigm, you don't really care how something gets executed or how something gets done. What you care about is what the result is you want to get. So in SQL, for example, you don't really know where the information of the database is stored in your disk, right? You don't know where the queries you write get the results from. You don't know how they do it. You don't even care about the algorithm. The only thing you care about is trying to write a query, then trying to get the result that matches your query. So this is like a way of doing things in logical programming. You write something, and then that written code will get executed however it gets executed. You don't care about that. You only care about the results that will get back to you. So logical paradigm is more of like a programming paradigm that focuses on that focuses on what you get instead of how you get something. So MeTTa also has these kinds of behaviors in its atom space and pattern matching and stuff. So we will cover that in our next session. But the way you do it is you define something in your atom space. You try to retrieve it using some kind of query, but you don't really care how that query gets executed. So it has this kind of support for you as well. So that's more or less what you need to know for these two different paradigms. So MeTTa has a combination of the two. So it's not purely functional, it's not purely logical, it's something as a mingling of the two. Alright, so if we said such much about the paradigm of MeTTa, we can go about what else makes MeTTa unique. So another feature that you may find in MeTTa is knowledge representation. So MeTTa tries to represent things using graphs and hypergraphs. So graph is basically a data structure, as you may be familiar with if you're in a computer science major, is a data structure with nodes and edges. So there are some nodes that have some values, and there are some edges that connect two nodes together, like sort of like a relationship between two nodes. So an example might be, a famous example in MeTTa is also a family tree, for example. You may have a father as a node and a mother as a node, and their connection is going to be written using some kind of age. Let's say your father and your mother might be married, so their age could be they are married. So that kind of relationship can represent this graph. So that's an example of a graph. A hypergraph is just a more complex form of graph, and instead of an edge connecting two nodes, you will be connecting multiple nodes. So you don't need to bother about this a lot, but just to give you what MeTTa uses, the Java structure MeTTa uses to represent information or knowledge in its data. So the benefit of this is that you can represent more complex things, and you can represent things that are more suitable for like AI or AGI-ish research. So that's the main benefit of having the support for hypergraph and graphs as well. All right, another thing you may be encountering here is the Hyperon or Hyperon framework. Hyperon is like an AGI framework that you will that we at Singularity at IcoGlab are trying to build. So this AGI framework is a combination of different AI algorithms that have been around for quite some time right now, and it's going to bring them together in a unique way so that they can interact and evolve into a greater AI architecture and algorithm. So the Hyperon approach is a little bit different from what the current state-of-the-art AI models are trying to do, which is training a very large neural network on a very large data set with very big and powerful computing GPUs. But here, this infrastructure, this architecture is trying to do the same thing, but instead of using the big neural network alone, it's going to also utilize some more structured software kind of approach. So you have different algorithms interacting in a different way, trying to solve different parts of problems, which independently may be too simple to seem like it's going to give you an AGI, but together they become more powerful. In a sense, the parts are somehow greater, the whole is somehow greater than the parts. Alright, so apart from that, we also have a storage called the atom space. So this terminology may be thrown around a lot of times in MeTTa training. So an atom space, you can think of it just like a graph database that is going to be used to store anything. It can store both code or data. We'll cover this in the next session, but that's what an atom space means inside MeTTa. So another thing you may ask is what else is making MeTTa new? Why do we need this programming language? So as I tried to mention the first time, the first thing is going to be its unique requirements for this Hyperon infrastructure we're trying to build for AGI. But apart from that, it also have very interesting features. The first one is its support for a hypergraph. The second one is its support for pattern matching, which will be covered a little bit in a little bit in the next session, which is going to be the way you retrieve data from your atom space. An atom space is something you store data in. We talked about the one slide ago. So it's like a graph. It's like a database. An atom space is like a database. A pattern matching is like writing a query to retrieve information from the database. And another interesting part is going to be a Python integration. So a Python integration is needed because MeTTa is a new programming language, and Python has been around for quite some time, and there is a lot of community over AI, especially in the neural network side. So you may want to utilize some libraries from Python, or you may want to integrate your graph database with some kind of LLM modules or neural network modules. So this Python integration will allow you to do that, because you don't want to redesign every library in MeTTa because it's a new language. So that's also one of the most powerful things about MeTTa. You can integrate to any Python logic. So the integration is mutual. You can run Python code from within MeTTa, or you can also run MeTTa from within a Python code. So one thing that I would like to mention about MeTTa is that it has a very flexible representation. It has a very limited set of built-in types. Not only that, it also has similar representation for both your code and your data. So as an example, if you see a Python code, for example, if you are trying to access some long-term data, you have to open up a file and read the file into your memory, which changes its representation format, and then your code can access it. So if you could want to understand your file, you have to turn changes in a way that's more understandable for your code. So there is a middle code that tries to convert the information. And the file and the code, they are completely different and separate in the storage and also in syntax and everything. So if you potentially want, for example, say to modify the code, the Python code itself, it's going to be a little bit harder in any other programming language. So because it has a different representation, if it tries to process a Python code, you basically might need to write a compiler before you can be able to do that, because the Python language has a very completely different syntax. It's more complex than the file or any of the files that you have been manipulating using that Python code itself. But when it comes to MeTTa, both data and code have a simple syntax, which is this list-based syntax, where everything is wrapped around in a bracket. We will see maybe an example of that in next session. So you have this same representation both for your code and for your data, and you use that to represent, again, both data and code. That gives you new possibilities, because now the code and the data have the same representation. So if your code wants to modify the data, it can do that very easily. But again, if the code wants to modify a code as well, it's still very easy, because the representation is the same. You don't need to do a lot of weird things because the data is the same. So you can use built-in MeTTa functionalities to just interact with the code like as if it is a data itself. So this will allow us to write some algorithms and some logics that are self-modifying and self-rewriting, which is very meaningful in the context of AGI, because AGI, we wanted to get involved and we wanted to learn new things and get more and more complex over time. So we wanted to be able to modify itself very easily, which this programming language allows us, again, very easily. All right. So some of you might ask, all right, well then what else can I do with this programming language? Well, as I tried to mention before, the primary objective of this programming language was to build this AGI infrastructure called Hyperon, but it's still very useful in other domains as well. So the first thing is the cognitive architecture. If you are thinking to do any cognitive architectures, which is actually some of somehow the inspiration for Hyperon, you can use this MeTTa language to write basically anything. So it's like any other programming language. You can write any logic using it. You can also use different Python libraries as an extension for it, so you can integrate it with them as well. But in addition to that, you can also simulate some other cognitive algorithms in a MeTTa environment, because it's actually easier to do some of the things that cognitive algorithms are doing within MeTTa itself. Well, I keep saying cognitive architectures, but I didn't really explain what it is, but it's basically an AI algorithm approach which tries to get its inspiration from how our minds work, not in a neural level, but in a psychological level. So you have different components in your mind. So you have a memory, you have a reasoning place, you have a learning module or learning capability, or different functions of your mind. So you bring all of these together and you try to mimic them at a surface level in an algorithm. That's how you get a cognitive architecture. When you come to a neural network, they try to replicate the brain at a neural level. So whenever these neural levels get interconnected with each other, they get more and more complex things, and they usually it's more controversial, but it says that they developed some of the functionalities as well, but it's very highly very hard to verify them. So I haven't seen a paper on a verification of them, but it is possible to verify these as well. But cognitive architectures are a bit different, and that's also the inspiration for Hyperon, but you can also, that's why it's easier to use MeTTa for other cognitive architectures as well. So another one would be knowledge representation. So if you just want to use MeTTa for its graph representation and for its hypergraph representation, that's also possible. You can use it as a graph database alone, and you can store information inside there. You can query the information, integrate it with the rest of your algorithm. Maybe some of you would like to integrate it with an LLM application for some kind of RAG kind of applications. So it's also possible. You can represent different ontologies, relationships, or semantics using MeTTa itself. Anything that you can represent with a graph, you can represent with MeTTa very easily. Another one would be reasoning engines. So this is also part of partly from a cognitive architecture, but it's a system that you can build that is inspired by the way how humans reason. So you have different reasoning rules for humans that we humans use, so you try to mimic them within a computer. You have some predefined facts and some predefined rules that together, when they combine with each other, you get some meaningful result, and you can also interpret how that meaningful result came about. That's the main benefit, because in other LLM models, you don't really know where the result is coming from. You train it on this gazillion amount of data, and then as an output you get something, but you're not really sure where that something is coming from. Now, that's one of the most dangerous for LLMs, as well as one of the main reasons we can't really improve them, because we don't really know why they're getting these results in the first place. Another example might be an expert system. It's all connected to the ideas I mentioned here, but these expert systems are just they were previously very popular. They have a different approach to building neural networks and building AI algorithms. They use facts and they use rules, and they try to combine them in a different way so that they can get some kind of output in the end. They used to get a very interesting result, but now, since we have a very big compute and a very big amount of data, we are moving into neural networks, but you can also experiment with expert systems, and then now maybe the research is also trying to move into a neuro-symbolic approach, which is trying to merge the current state-of-the-art neural network approach with some of the ideas that were popular during the expert systems, and this neuro-symbolic approach gets everything it gets very interesting results, and people have also been focused on that for quite some time now. Okay, so why is MeTTa essential? So the main reason we need this MeTTa reprogramming language in the first place is to find an AI algorithm that solves the current limitations of LLMs. That wasn't how it was started in the first place, but now, since we have a lot of popular models, we can sort of solve their limitations using MeTTa. The first limitation is going to be the hallucination. As I mentioned earlier, hallucinations are very common when using LLMs. You may have encountered some of them as well. But the main issue is you're training it on a big data and you're not really sure where to correct it, and the AI can make mistakes here and there. The mistakes can pile up, and in the end you may get something that's completely off track of reality, and you're not really sure why that's happening. This is the biggest limitation of LLMs, but if you're using MeTTa, you have some way of trying to explain why the results are the way they are, and you can potentially correct them. You can even have the AI system correct itself by you giving it some kind of fitness measure. That's also a possibility. So one of the reasons is to fix the hallucination, and the other one is to fix the long-term reasoning issue. So LLMs, they have a very short-term vision, so they are just predicting the next token. Still, they're doing very incredible and amazing stuff, but as a humans, we most of the time don't really work that way. We also have a long-term plan, short-term plan, depending on the task we're doing. We can switch between the two. That's part of how we get successful in executing different things. So that's also part of the solution that MeTTa is offering. We can also do some kind of long-term reasoning as long as we decide what to use for that one. So another one would be it's a very simple and flexible environment where you can integrate different platforms. So you have a Python integration inside it, and the programming language supports different features like a functional programming language, which is very famous amongst mathematicians, and logical programming language, which was famous when we were doing some expert system back in the day. So that bridging paradigm feature is also a very interesting one. The last one, as I tried to mention it in the first point as well, is being able to build an explainable and robust AI. So if you can explain why an AI gives the output, then you can potentially make it more robust by improving it itself again and again. So that's also a very good potential for MeTTa. So that's pretty much it for what we have for today. And if you haven't set up MeTTa already, please make sure to do so. The command is very simple. If you're on Linux, it's even simpler. You just have to install a Python package called Hyperon. If you're on Windows, still you just have to set up a Python package called Hyperon, but the setup on Windows tends to be a little bit more cumbersome sometimes. So if you're still wondering how to do that, you can go through some of our YouTube tutorials. We will be sharing them in the material so that you can get yourself started with utilizing MeTTa. All right, that's all I have for today. Thank you all for your attention. Please feel free to reach us out if you have any questions. ታይመር ያስ ከፈለክ ታይመር ያስ በስልክ እዛው ለማየት እንዲመች ይቀለጣ ትንሽ ለማብራራት ነው ይላል። መስቲ ፕላትፎርም የሚወጣው በኋላ እንነግራቸዋለን። ችግር የለውም። አንዳንድ ፓረንት ብላችሁ ካለ ሁለት ፓረንት ካላችሁ እንደዛ ብታደርገው ይቀንሳል። We're going to become under. Yeah, የዚህ መሆን የለበትም ብላችሁ ረስችሁ ይቆረጣችሁ ግን እኔ ሪከርድ አድርጌ ስቲል እያደረገ ነው መሰለኝ። ኦ ማይ ጋድ